The biggest trap with modern AI is not that it fails, it is that it sounds certain while guessing. In real organizations, that confidence can turn a suggestion into an action, and the action can become irreversible before anyone notices the reasoning was brittle. By 2026, frontier systems can look like they are doing multi-step thinking. They can break problems into parts, call tools, write code, retrieve documents, and produce explanations that feel probabilistic. Yet reliability still drops fast when the world shifts even slightly. A new market regime, a novel adversary tactic, an unexpected sensor failure, a policy change, or a weird edge case. Hidden variables show up, goals get ambiguous, and the causal structure is underspecified. Under those conditions, the model may still produce a clean answer, but the clean answer is the danger. One important insight is that better benchmarks do not equal open-world competence. Many gains come from tightly framed tests. Outside those frames, systems still stumble on common-sense gaps. They miss premises that humans supply implicitly. They struggle with spatial reasoning, object permanence, and messy social context. If a task requires inferring a missing constraint, a system may fill the hole with a plausible invention. That is not a minor glitch. In operations, it becomes a confident falsehood that travels through trusted workflows. A second, deeper boundary is causality. Prediction and causation are not the same skill. Correlations can rank likely outcomes, but they do not explain what would happen if you intervene. Leaders often need intervention, not description. Should we change pricing, reroute logistics, adjust a clinical protocol, shut down equipment, or deploy capital into a stressed system? Counterfactuals, responsibility assignment, and explanations all require assumptions about what causes what. Statistical pattern matching does not supply those assumptions by default. If the system recommends an intervention, someone must own and review the causal story, not just the forecast. There is also a humbling fact about human oversight. Humans are not the gold standard of rationality. People make systematic probability errors, including conjunction fallacy-style mistakes. We overweight vivid narratives, defer to authority, and get sloppy when tired. So keep a human in the loop is not a safety plan by itself. Oversight must be designed. Reviewers need structure, clear thresholds, and the right information at the right time. Otherwise, the human becomes a rubber stamp, especially when the machine sounds fluent. That brings us to what may be the most practical frontier for the next few decades. It is delegation design. Not, can the model answer, but what is the model allowed to do? In a serious institution, you need explicit boundaries for what a system may infer, recommend, execute, refuse, escalate, or quietly archive. You also need auditable uncertainty handling and named human authority at each boundary. Without that, you get responsibility laundering. The organization acts, then later claims the machine decided, and nobody can point to a legitimate accountable owner. Uncertainty deserves special attention because it often disappears in workflow plumbing. A model might internally represent doubt, but downstream, a dashboard turns it into a single green light, or a ticketing system converts nuance into a binary approve or deny. Once uncertainty is compressed into certainty, the social system treats the output as authoritative. Preserving uncertainty end-to-end is not a nice feature. It is a control surface. It lets teams decide when to slow down, when to seek more evidence, and when to escalate. Distribution shift is the silent killer in that same pipeline. A system can be excellent on the training-like cases and fragile when reality drifts. So acceptance testing cannot just replay yesterday's data. You need evaluation regimes designed to detect shift before you delegate real authority. That can mean stress tests, adversarial probes, scenario variation, and routine calibration checks. The goal is not perfect prediction. The goal is early warning that you are outside the model's proven envelope. Over the mid-horizon, roughly 2050 to 2100, the most credible path to improved reliability is hybrid reasoning. That means combining neural models with other methods that carry explicit structure. Symbolic constraints can enforce rules. Probabilistic inference can quantify uncertainty. Causal graphs can make assumptions visible and versioned. Retrieval can anchor claims to evidence. Simulation can test interventions in a model of the world. Formal verification can prove limited properties in bounded domains. None of these solves the whole problem alone. Together, they can produce systems that fail more gracefully and can be audited when the stakes rise. Even then, the hard limits are not only engineering. Some are physical, like finite information, noise, the thermodynamic cost of computation, and time-delayed evidence flow. Others are coordination limits, like authority, legitimacy, consent, liability, and institutional memory. Those coordination limits are why deep horizon fantasies of fully autonomous governance remain speculative. Computation can optimize within a set of values. It cannot, by itself, legitimately choose the values, resolve contested rights, or perform moral repair after harm. That stays in the realm of governance, identity, and accountable authority. For leaders allocating capital and authority today, the practical move is straightforward. Budget for evaluation and governance infrastructure before you scale deployment. Treat calibration testing, shift testing, red teaming, causal assumption review, audit logging, and incident analysis as core production costs. Demand that vendors specify how systems behave under uncertainty, including refusals and escalation triggers. Staff mixed teams, not just model builders, but domain experts, statisticians, causal specialists, security, and a business owner who is on the hook. One question is worth sitting with. Which recommendation systems in your organization have quietly become automated approvals because humans almost never override them? If you cannot answer that precisely, you have already crossed the machine reasoning frontier without admitting it. In the long run, the advantage will go to institutions that treat reasoning as an accountable process, not a confident output.